Hi, I'm Ben Brownlee for Boris FX, and we're going to be taking a look at getting started with the new camera module in Mocha Pro. So we're going to start off easy and then we're going to dive deep into some of the more advanced features. So here is our first shot, and it shouldn't offer us too many problems when we're coming to do 3D tracking on this. If I come up to the workspace drop down menu in the toolbar, you'll see we have a brand new one that's called Camera Solve. So coming into here gives us all the tools that we need to work with the new Camera Solve module. And you'll see that we have two new panels over on the right hand side. Now the Camera Solver found in Mocha Pro 2024 and above is completely different to the older Camera Solve that we had in previous versions. So old projects where you've used the original Camera Solver will still have that data when you open up the project in Mocha Pro 2024 and above, but the only thing you'll be able to do with that data is to export it. You'll only have the new solver parameters available to you. Now, this Camera Solver is powered by Boris FX SynthEyes, and it's designed for a user-friendly camera solving experience. So there are very few controls that we have here. Now, when it comes to camera solving, the biggest button is the most important. This is our solve button. So this is going to run an automatic solve for us. It's going to find the points that are of interest. It's going to align the scene. It's going to solve the camera. It's going to do all of that in less time than it took for me to actually say all of those things. And if we just play this through, you can see that we've got our points that are aligning to the floor and sticking in there. And that's looking pretty good. We also have a ground plane stuck, well, halfway up the scene actually at the moment. And we also have an origin point, which is where the three axes all come together. So let's come in and just set our ground plane. All I'm going to do is I'm going to click and drag all of these trackers here. And I'm going to shift, click and drag some of the trackers over there. In fact, let's just drag or select all of the ones that are on the ground plane there. And I can come over to my new 3D panels. So over on the top right, we see the 3D objects, which lists all the objects we have. And we also have the 3D object properties. Again, we'll come into more details on those soon. But at the bottom, we have this align area. So we can align the ground plane to the points that we have selected. Boop. And you'll see that we had a little bit of an adjustment there, but not a lot of things changed. So if I have only one point selected, over in my align controls, I have a button pop up that says make origin. So if I click on this one, we can see my three axes now pop to that point as my origin point. This is where 0, 0, 0 is going to be. This is the center of our scene. So if I play this back now, you can see that that ground plane is properly aligned. We've done our auto track, we've aligned our scene. The last thing we're going to do is we're just going to export that camera data. So coming back into our solve data, I can choose what type of camera data that I want to take out, any of these formats, and then I can just save them or copy them to the clipboard. Now what you do with this camera data is definitely worth having videos of their own, because every single host application is going to work with that data slightly differently, but we'll talk about those in other videos. And that's really, the basics of it. If you just want an auto track to come in, you click on solve, you align your scene, and you export the camera data. Really, really easy. What if we want to go a little bit deeper? Well, let's clear our solve down in the Camera Solve and let's walk through this process a little bit slower. So the first thing I'm going to do again is I'll leave everything at the default settings and I'll click on the Camera Solve and take a look at the top right hand corner when we do that. So it's going to go through a series of processes to work with this. And it's going to say things like blipping, peeling, solving. And let's talk about those words. So when we're breaking things down like this, what we're looking for is we're looking for features first. So a feature is any sort of point of interest in the shot that might be useful to track. So it could be, something like this, these lights up at the top here, just, this light shape here, or this little area down on the wall, or any of the other hundreds of points that we have possible in this particular scene. Now these can either be auto features, so something that the camera solver finds for us, Or if we want to have those features in a specific place, we can use Mocha's planar tracker to track in individual points. And we'll take a look at that in the next shot. The process of creating these features automatically starts with blipping. And blipping is a SynthEyes term, which means it looks at the shot and finds all of the points of interest in them. When it's done that across the entire range, it then tries to find the paths of those blipped areas. It then takes those best ones and turns those into trackers in a process that's called peeling. We end up with 2D trackers. The next stage is to solve the camera. So by doing some quite clever maths, it turns those 2D trackers and finds the relationship between them, turning them into 3D trackers, which is what we actually see here. As I scrub through, we can see these are 3D trackers, because if I come up to my viewer choice up here, we can take a little look at these in perspective, and we can start to move around the scene and see these in 3D. And if I play this through, we can see the camera is also tracked inside there. After we've done the solve, we have one more process, which is a cleanup phase, where it takes away bad trackers that have a too high an error rate, and sort of cleans up those areas there to give us our nice tracked in scene. So how can we tell whether this is a good solve or not? Well, probably the easiest way to look at it is to come down to this bar down here. This is our HPIX graph, and this is showing us the average error of the currently solved 3D trackers. And HPIX stands for horizontal pixels. And what this really is the difference between the position of the 2D trackers, the unsolved trackers, and the 3D points. So what happens when these are actually solved in. So any sort of drift between where the 2D tracker was in the start and where the 3D point is, that is our HPIX error here. And again, this is the average error. So we could have individual feature points here, which have a very high error. So then they're really not sat in the scene very well. As a rule of thumb, anything of 1 pixel and below is considered a good track. Here we're at 1.04. It's pretty good. It's pretty good. And I'd probably be happy to export this. But there are other parameters that we can change to help this out as well. And let's start back in the camera solve parameters. And the first one is the focal length. So this is the 35mm equivalent of what the focal length of the lens that was used in this shot is actually going to be. The focal length isn't the distance between the camera and the area that's actually in focus. When we're talking about focal length here, we're actually talking about the focal length of the lens. So here, this is a 28mm lens. So on a full frame camera, there's going to be 28mm between the lens and the focal point. And if I take a bigger lens now, this is a 300mm lens, which means we have a much larger gap between the focal point of the lens and the sensor itself. This focal length parameter is actually pretty important, especially when we start to take this data into other host applications and start to work with it. Now, the way of thinking about it is that shorter focal lengths have a larger amount of parallax within the image. So the speed at which the foreground points move is going to be relatively or greater, relatively speaking, than the ones in the back, than with a longer lens. So with a longer lens, you'll see very, very little movement or very, very little parallax movement within the equivalent sort of shot. The other important thing to think about with this focal length is it is an equivalent length of what it would look like on a 35mm camera. So like taking a look here, like it doesn't have to necessarily have to do with the actual physical size of the lens. Like this is a 28mm lens. This is also a 28mm lens. This also has a 28mm equivalent lens. So just looking at the size of the lens itself isn't necessarily a great way of judging what value should be put in focal length. We can see here that the solve value of this particular camera was 13.3714 millimeters, which is quite a wide angle lens, which actually makes sense here. And that's why I would suggest that we keep this set to unknown, especially in the first instances, because even if we do know the actual lens that was used, we also need to do calculations based off of the film back of the camera, like the sensor size, and all of that other sort of fun stuff that you might not have to hand. Also, any sort of optical flaws in a particular lens would also send that value off a little bit. Like this is rated at 28 millimeters, but maybe it's 28 millimeters 0.14 or 0.014, something like that. You know, the actual physical process of creating a lens isn't always perfect, except on this lens, which is perfect, and I love it. The other thing to think about is if you're using a zoom lens, and if you're zooming within that shot, that focal length is going to be changing. If you do that, you need to make sure that you click on zoom lens down there. So if the focal length changes throughout the shot, have that selected. Just because you're using a zoom lens doesn't mean you have to have that selected. It's only if you are zooming within the shot. So with that being said, what can we do to improve the error rate here? Well, one of the things is coming into our features area and maybe making some changes within the features. And we'll just stick with auto features to begin with. We can also look at upping the minimum number of trackers per frame. So at the moment this is set to 12. So if I turn this up, it means we have guaranteed more trackers within the frame, and we're probably going to be reducing the number of short trackers that we have to work with. So it's going to give us a better result, especially on longer shots. The other thing we can do is we can crank up the maximum tracker count. In fact, we can crank this up to a ridiculous level. I would never have it set this high. Now, the consequence of having this maximum tracker count set up too high is that, yes, maybe we will have more features at the end of it, but are they going to be the right features? And we're just going to be giving ourselves a lot more feature points to manage over on the right hand side, and it was also going to blow up the amount of time that it takes to calculate the solve. So the more features we have here, the longer your solving times are going to be. So the default is 120. Actually, we'll crank this up really high. I would never crank this up as high here. I'm going to put this to like 1400. Click on solve, and we'll see what a difference that makes. One of the biggest consequences I can hear so far is that the graphics card fan is spinning up. We're definitely making it do a little bit of work. And once that's solved, we can take a look at our average error. That's now down to 0.98, looking pretty good. Let's take a quick look in our perspective view here. We definitely get a different view of what's happening within our scene. We can see the curvature of the building. And if I open up my feature points, our feature point list is now, rather extreme. At the end of it, we have 1,339 valid vertices. Whew, it's a lot to worry about. Huge amounts of trackers don't always mean more accuracy. As part of an auto solve, the minimum number of trackers is probably more important. So when we're in that cleanup phase, fewer of those trackers are going to be automatically culled, leaving you probably on average with some worse tracking. Let's take this down to 320. That should be perfectly fine. The other thing to worry about is the blip size here. So what is a good blip size? Well, this depends on a number of factors. The first one is probably the resolution of your shot. Like the blip size is measured in pixels. So how big are those features that you're going to be looking for in the shot? If we have a high-res shot with lots of detail in it, like we do here, this is a Ultra HD shot. We have lots of nice fine details. A small blip size of 7 pixels, that's going to pick up a lot of details. That's going to be nice for us. If all of this scene was out of focus, that blip size at 7 probably not going to pick up anything really sort of interesting for us. So we'd have to bring our blip size up substantially. So let's bring that up to 20. That's quite a high small blip size. And then our big blip size, that's the size of the larger features. And, you know, rule of thumb, have the big blip size twice the size of the small blip size, just to get a bit of variety between those two. So let's solve that again. I'm going to click the big solve button. This should solve quite quickly now because we have a smaller maximum tracker count. But you can see my average error has shot back up again over that 1 pixel value. It's not too far over the 1 pixel value, but it's not great. So let's take my small blip size down again. Take that back down to 8. I'll take my big blip size down, 16. Let's run that solve one more time, not change anything else. Remember the average error before was 1.12. We now have an average error of 0.999. Goodness me, that's pretty good. The other thing you'll notice is that every time we run a new solve, we have to do a new set of alignment. It's going to try to auto align to a ground plane again. So let's do that same thing as we had previously. Let's select our align to ground. We'll select our make origin. Happy with that. Have a little look through in perspective mode again. Now, navigating perspective mode is fairly straightforward, and it's probably a good idea to have a 3-button mouse, just like working with any 3D application. By using the scroll wheel, we can zoom in and out of our viewer. If we click and drag with the middle mouse, we can pan around in the viewer. If we hold down Alt and left click, we can rotate around and our viewer here, and we are rotating around the origin point. And if I have Alt or Option held down and use the right mouse button, I can dolly in and out of my scene. Very nice. But what if we want to go even further? Maybe we've got a slightly more difficult shot. We want to add in some garbage masks. We want to use Mocha's planar tracker, or maybe even the power mesh to help to drive some of this tracking data. But that we're going to save for the next part in our getting started with the camera solve module in Mocha Pro. My name is Ben Brownlee for Boris FX, and I'll see you match moving some more shots in the next video. If you have any questions about the new camera solver, please leave them in the comments below. If you want to go deeper as well, we do have a Boris FX Discord channel and Boris FX forum, links in the description below. Of course, if you don't have Mocha Pro already, check out a free trial at borisfx.com.